6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome out there. It is T and Learn Mathline, summer school style. I know it's been warm, it's hot days, all sorts of good things. You're enjoying summer. Glad you're with us this afternoon on T and Learn Mathline. I'm Ernie Roberts. I am your host for this afternoon's session of summer school. Now in summer school, we try to be a little more laid back and such. And you know what? A lot of the things we're doing with summer school is remediation, review, helping you to be ahead of the game next fall and in August when you go back to school, all right? So, hey, that's what summer school is all about, right? We'll have a little bit of fun while we're at it. Relax, get those pencils, get some paper out. It's not a call-in day, all right? But you can still send us messages and still send us information via Facebook, email. If you got some problems, we'll address them sometime over the course of the summer, all right? But do that, take care of those things. But let's have some fun today, and let's see where we're going today with this problem-solving session. Yes! Ooh, fraction action part 6. I think that's about the end of this one, by the way. Triple the fun. Triple the fun. You say, how can you triple the fun? Well, you know, we're going to extend those fractions a little bit longer. Probably have 3 or more fractions involved in each problem. That's called fun, all right? And fraction action all the way, all the way. So let's see a good example of something with 3 or more fractions involved right here off the bat. This one tells us we're going to arrange these fractions in order from the least to the greatest. And you look at those and you say, wow, Ernie, that's interesting. I think it is too. I've got 2/3, 5/6, 3/4, and then 7/12 out there. And we want to see which one is least, what comes next, and then what finally is the greatest. Now, they might even be in order already. Some of you are going, I bet that 7/12 is the biggest because it's got a 12 in it. Well, you know, we really can't tell until we make all of these numbers. So go ahead and write these, and all these numbers the same denominator. So 12 is important maybe, as are 2, 3, 6, 4, all those numbers. Everything on this problem is important. So let's write them down at home, see where we're going to go. Got 2/3, got 5/6, 3/4, and last but not least here, 7/12. Or maybe it is the least. You don't know. We don't know. We're going to find out. We're going to find out. Now, what does it take? What does it take, you say? Well, we need to find a common denominator, something that all 3 of these denominators will divide into evenly. That's what we need. That's what we're looking for. So I look at 3 and 4, and I notice that they're right next to each other. And I know 12 is the number that they're going to go into. Well, that's good news. That's really good news because 3 times 4 gives me 12. I've got a 12 already. So that takes care of 3, 4, and 12. The question is 6 taken care of? It certainly is. It certainly is because 6 will divide into 12 evenly. So we have our common denominator, our least common denominator, in fact. It's going to be 12. So let's put 12s down here in all of these lovely numbers. And you know what? There's already a 7 there. We don't need to worry about that. We don't need to worry about that. Now, I hope you guys have been tuned into some of the problems and programs that we've been looking at the last week on Mathline and last week and through the course of the summer, because we've already done problems like this. So we're going to move this pretty quickly, all right? So how we go about it, we look at ourselves and say, and we ask ourselves in our head, I don't know, we always look at ourselves in the mirror and ask these questions, but we are going to say 3 times some number gets us to 12, all right? And that number is 4. We must multiply the 2 by that. That's going to give us 8 right up there in the numerator. Now, how about it? 6 times some number gives us 12. That's 2. We know it goes in 2 times. How about it? 5 times 2? I'm picking up 10. Well, I just told me 10 is certainly larger than 8. So let's keep going with this, see what numbers we've got. Then both of these, by the way, are bigger than 7. All right, so those of you who thought 7/12 was the answer, and it doesn't look that way. All right, certainly not going to be the greatest. It might be the least at the rate we're going. Let's see, 4 times some number, it's going to be a 3. 3 times 3 gives you 9. My. This one looks like this is your first. This is the least, okay? This one comes 1 unit later. It's going to be second when we list these. And here comes 9/12, which is going to be our third. And then last but not least, oh definitely, last but greatest on this one is going to be 10 over 12. Now, when we come back and write these down, we want to come back to these original fractions. We don't want to leave them just like this. We want to put them in order, and we're going to go back to the reduced form. So let's drop that lower third out of the way, guys, and we're going to write right down here with it. I got 7/12 starting me off because that is my smallest fraction, all right? Notice, once you get all the denominators the same, then it's easy to compare. It's so easy to compare. So we got a 7/12, and that was what it was originally. So that's why I'm writing 7/12. Now the rest of these I'm going to have to go back to the original fraction. And it looks like 2/3 pops up next. That goes with 8/12. The 3/4 is going to be our third one because it's matching up with the 9/12. So here we go. And last but not least, actually last but greatest, exactly, we get 5/6. There is your order. Hope you all got that going there. And again, it's all about common denominators and compare your numbers. Compare your numbers. Easy? It is if you can do multiplication and you can also get a common denominator. And remember, you've got to change all your numerators in proportion to what you did with your denominators. So important things, yes, whatever you do the numerator, do the denominator. Whatever you do the denominator, do the numerator. Rules of fractions, rules of fractions. And important rules, by the way. It works also when we add. So let's take a look at an addition problem coming up here, all right? So it's going to be a potpourri of all sorts of things. We've worked with ordering, comparing. We've worked with adding, subtracting, multiplying, dividing. This one is going to be a pretty much straightforward addition problem. And remember, common denominators are the rule. That's what we have to do. So write the problem down at home there, everybody who's watching. Yeah, go ahead and write that down. 2/3 plus 3/8. And then we'll tack on a 1/2. I'm going to leave a little gap here so we can expand as we need to on these fractions, all right? Obviously, I need a common denominator once again. Now, I look, and sometimes I find it quickly. I look at 3. 3 is a prime number, all right? And I look at 3, and working with 8, 3 won't divide into 8 evenly, so I basically know I have to multiply those two numbers together. One's a prime, and while 8 has factors, it has no way to divide 3 into evenly. It's only when I get this nice something that divides into 8 evenly, hey, like that 2 over there, that I don't have to worry about just multiplying the 2 and getting a bigger number, all right? So I'm going to go with this, though, because I do need to multiply those two numbers together. 3 times 8 is going to give me 24. I also know, since 24 is even, that 2 is going to divide into it evenly, so 24 is as good as it's going to get. Now, yes, I could go larger, but as good as it's going to get means LCD time, least common denominator. Now, talk about it again. Let's look at it. We've got 8 times 3 to make this work, to get to 24, which means that numerator up there must be multiplied by 8 also. Know your times tables? Of course you do. Double 8, or 2 times 8, I get 16. That starts us off very nicely here. All right, this little guy over here, we multiplied him by 3. So we got to do his numerator by 3, all right? So the denominator hits the 3, so does the numerator. By the way, just remember a little thing about that. This 8 over 8, why can we do that? Because it's basically multiplying by 1. 8 over 8 equals 1. So when we multiply this through, we're really not changing the value of 2/3. We're just renaming it with a denominator that's different, which means the numerator is going to have to transpose a little bit too. They're always in proportion. Same thing here, 3 over 3, multiplying by 1. Now, we're not doing by 1, though. We're wanting to get that 3 times 3 effect because we got to have it. So we put a 9, and the plus hangs on right there in between. Lovely. Now, how about it? 2 times, we got a 12 going over here. Put a 12 on the edge. Again, take it to the numerator just as well as you do the denominator. And we've got a 12 here, and we're going to add. We're going to add these up, and we're going to add them correctly, right? Everybody good on that? Think about money if you need a little help mentally on this. 16 plus 9 is going to get us to 25. That's a nice number. It's like a quarter. But then we're going to add 12 to that. Actually, it's like $25. Let's talk about it dollars maybe. 25 and 12 gives us 37. But we got to divide that out by 24. Got to think a little bit here. Goes in there one time. Remember, that's why everybody understands fractions of division. So this base is saying 37 divided by 24. We know it'll go in there one time, and it's going to have 13 left over. And we want to make sure we put that 13 back over the 24. Don't put it over 37. Been known to do things like that before. That's called carelessness. But catch it. If you should go careless on me, be sure you catch it. But 1 and 13 over 24, or 13/24ths, if we like to call it that. So again, when we add, we want to make sure we can come back to, in this case, lowest terms we would call a mixed number. This is lowest terms also, 37 over 24. It's improper. We can always take it back down to that little mixed number. And we're going to talk about mixed numbers on down the summer here somewhere, I guess. But today it's all about just basically fractions, and sometimes the results will pop out in a mixed number status. All right, so that's our story. I'm sticking to it. Hopefully you are too. Let's take a look at our next problem. A little bit of a mix coming up here. A little bit of subtraction and a little bit of addition. I like this one because it makes us have to remember, what do we do with the order of operations? We always think about my dear Aunt Sally. And sometimes we take that my dear Aunt Sally a little too literally. Like M and D, multiplication, division. That doesn't mean multiplication is done before division. That basically means my dear is done together. They are taking equal precedence, whichever comes first. Same thing about Aunt Sally, adding and subtracting. Here subtraction comes before addition. We go that way, all right? Addition and subtraction, no matter what comes first, they get equal treatment at that point in the problem. Now, parentheses can tell you to do differently, but we have no parentheses here. Actually, we have no exponents, no multiplication, division. It's all about subtracting and adding, and we're going to work this left to right, because that's what the word's got to do. That's the way we do that mathematically. And before we go anywhere, we can't subtract either unless we have common denominators, nor can we add. So let's get a common denominator for all three. Triple the fun, right? Got it. Got 3 of them here. So let's go with it. 1/3 minus that 1/6. This one's a pretty reasonable denominator. In fact, it's a real easy one. It's rather small. In fact, it's staring at us. It's staring at us because 2 will go into 6 evenly, 3 will go into 6 evenly, and certainly 6 will go into 6 evenly. All right? So here's this deal. Here's our deal. We're going to get 6s in each case here. All right? So tripling our fun and watching our signs. Got to watch our signs. Now, what's going on? 1/6 hasn't changed, so it's not going to change down here. It's going to stay the same. It's like multiplying by 1 or dividing by 1. Doesn't change. Now here, what will we do? We multiplied 3 times our 2, so we need to do, we got to do that 1 up there. And that 2 times 1 gives me 2. Oh, 2 minus 1. Did you ever think you were going to say 2 minus 1 gives you 1, right? Again, keep that in mind. It'll come back to haunt us here in just a minute. Actually, it'll come back to be our friend. Let's see what we do here. It looks like we are multiplying by, what is it, folks? Looks like we got to multiply by 3, which means we're going to add a 3 up here, multiply by 3, and then we'll add that result. Well, what do we get? We get 3. Now we're ready to click through this a little bit, all right? Now we're ready to click through. Before we click through, let's make sure we did everything right. Because we have the same denominator, it's all 6. We multiplied correctly here. We left this alone, and then we multiplied correctly here. So here's the deal. We have 2 minus 1, which gives us 1. Now we're going to add 3, and that gives us 4. Now, not just 4/6. Do we want to do what? Reduce to lowest terms, all right? So the simplifying part, we made it pretty simple. We got it down to 4/6, but we want to make sure we reduce on down a little bit further, and that becomes 2/3, because both those are even numbers. Divide both by 2. Interesting. Fun little problem. Yes, definitely a fun little problem there, and came out pretty nice. Hope you all got it right at home. That's what we do here. I want you to work through them with me, and then we check them as we go. Check them as we go. And that makes a good thing. Always double check, by the way. Make sure you do your right numbers correct, all right? Whew. That was pretty good. Triple the fun. Hey, about quadruple the fun. Let's look at our next one here. Actually, we've got 4 fractions. Count them. 1, 2, 3, 4. But 1, 2, and then a third operation. Notice I said 1, 2, and then the third operation. Because here, we've got to go through parentheses before we can do any of that final in-between subtraction. So, wow, this one's got a lot of stuff going on. Write it down, and let's see what's going to happen. I'm going to move right straight to common denominators here, all right? In that first parenthesis, I see 6, I see 12. I know 6 will go into 12 evenly. Makes me happy. You know why it makes me happy? Because I have a 12. And I have another 12 now. This one, the 5/12 here, stays the same. This one, however, did a little bit of adjusting. All right? What did we do? We multiplied the 6 by 2 to get to that 12. We're going to multiply the 5. We're going to do that mentally. And we're going to get 10 on that. All right? We'll take care of it in just a second. Everybody's getting excited. I know. We got a big subtract here in the middle. Now, let's work these guys out. Ooh, they're going to change quite a bit. Because 4 and 3 also, hey, about that, gives us 12. Common denominator, least common denominator nonetheless. Where are we going to go? Well, we did this just a minute ago, didn't we? We said 4 times some number. Well, it'd be 3 to get us 12, right? So let's get a 9 up there on top. And now let's go back to the 2/3 part. We multiply by 4. It's going to give us 8 right there. So what I'm seeing and what y'all are seeing, and everybody's hopefully seeing this, we got a lot of 12s. We got a lot of 12s. But remember what we got to do first. Go to your parentheses. Go to your parentheses. So there's 5/12. Ooh, a lot of subtraction in this problem in there. We will eventually subtract again. But let's go to this parenthesis. 9 minus 8. Forget about what's on there. See, my hand just covered it all up. And we got 1/12. Now this one's sweet. This one's really sweet. How about it? Gives us 4/12. So we've done a lot of subtracting on this. That means 1, 2, 3 subtractions. And now we've got to take care of that last moment, reducing to the lowest terms. Now, folks, if they don't tell you reduce to the lowest terms, you still go ahead and reduce it. It's just one of those things that's accepted and understood that you're supposed to do when you work with your final fractions. So take them down as far as you can, reduce them down best you can, especially when you start doing those probabilities and things. It just makes it look easier. And by the way, 4 out of 12, that's really nice because that reduces to 1/3, which is a lot easier to look at than all of the above there. All right, wow, how about that? And again, checking your arithmetic real quick, this one wasn't as hard as it looked, all right, because you had the 12s popping up everywhere. You ended up with a 10, keep that one the same. Over here, you end up with a 9, you end up with an 8, and the subtraction works really nicely. And you know, some of you said, Ernie, we just never get any negatives, do we? Well, if you do, you have to use the positive and negative rules. We're going for all positive answers today, all right, and not having to worry about positives and negatives in this show. But guess what? Summer school will probably come back to play in that realm sometime this summer, all right? So keep tuned, stay tuned, all right? There you go. Easy, 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 right? If you know what to do, All right, now we've added and we subtracted and said common denominator, common denominators, and compared common denominators. So let's take a look at our next problem, see what we've got coming our way. Ooh, multiply. We're going to multiply. Now, I want you to start thinking with me here a little bit. I know, it's summertime. Let's rewrite the problem first. Just put it down there. You all are at home, write it down with me. Let me put it down here. And this is where we got to think just a little bit. You know, do we need a common denominator here? Do we need a common denominator? Think about it. We could find one, but good grief, look what it is. 4 times 5, that would give me 20. Then I'm looking at 20 and 6. Whew, I was thinking 120, but you know, 60 would work. 60 would work. But that's about as close as this one's going to get. That would be horrible if I have to multiply 60 times 60 times 60 and then, we don't want to go there, all right? Even if we could cancel and say, well, you know what? We're going to have to remember, with multiplication, you don't need common denominators, all right? That's the big difference. When we're multiplying fractions, if you got them, you have a mess, okay, on this one, a problem like this. Let's go for another approach to make this easy. Let's simplify even before we multiply. We can do that. We can do that. Remember, you can, yes, everybody's out there going, I know what he's talking about. You can cancel on the diagonal. You can cancel vertically. The one thing you cannot do is cancel horizontally. All right? In other words, I can't cancel the 4 and the 6 out here, all right? And say, oh, 2 divides into both of those. No, no, no. We have to work from a different angle here, all right? So, what I can do, though, is cancel these 2 4s. They're beautiful because 4 will divide into both of them, leaves me with a 1 because what we're saying is divide 4 out of both. It's like taking care of The cancellation is just like taking care of multiplying or dividing through by 1 when you lose it both places, but you've got to be dividing by the same number in both cases here, all right? So it happened we ended up with 1 in both places because I set up the problems nice, didn't I? How about it? Go with the 5s. They do the same thing. You can divide 5 into both of these, again on the diagonal or vertically, it works. Now, some of you get a little nervous. You say, well, can we do anything with that 3 and 6? 3 will divide into 6 evenly. Goes 2 times. Obviously, 3 will divide into 3. It divides into itself 1 time. And yes, we can do that. We can jump across the parentheses as long as everything is multiplication here. And I say across parentheses, I should say across the middle term. There are no parentheses in this problem. Right. We'll see one of those in a minute probably. But what happened? We get a 1 and we get a 2. If there had been a parenthesis there, you would need to work out from there first, get a result, and then bring it back to your other term. For example, if we'd had parentheses here. Now, if we put them here, it would be just order of operations. They'd work beautifully. By the way, what do we got? No, the answer's not 2. We do have a 2 in the final result, but it's in the denominator. I have 1s up here that need to be dealt with. 1 times 1 times 1 is not, it's 1, all right? It's got to be there. In other words, it doesn't wipe out. It's not a 0. It's not something that just disappears and gives us a 2. It's 1/2. And folks, there's a big difference between 1/2 and 2. So again, this one was nice because everything canceled out. Yes, we could have multiplied 3 times 4 times 5 and put it over, what was it? Oh goodness, 4 times 5 times 6 without any cancellation. It'd be like 60 over 120. But you know what? That reduces to 1/2. It's another option to do it. Man, losing those 4s and those 5s, that's sweet. And even that 3 and the 6 was nice to cancel out some. So that's what you need to look for, make the problem easier for you when you're multiplying, especially when you start multiplying what look like rather larger fractions, okay? Certainly numbers that are in there, a little more difficult to work with. So we've done the addition, we've done subtraction, we got to divide. Let's go to a division problem here, all right? Let's see what we've got here. In fact, a little division and multiplication. Remember what I said a little bit earlier about poor old my dear Aunt Sally? It's a division and a multiplication. We work this one left to right. Let's leave the right with me too. So even though it sounds like MD, you always think, well, multiplication and division, but they get equal treatment going through there, all right? So we're going to do that first. So let's go back to 1/4. What do we do when we divide? We're just going to pretend there's a parenthesis there. It wasn't there originally, but it's left to right. So this is all we're going to worry about 2/3 in a minute, all right? It's attached. It's an afterthought. So let's see here. We're going to use the reciprocal, right? We're going to make that multiplication, which is going to give us 4 over 3. Then we can bring down 2/3 and work with that in just a second. We'll come back to that in just a second. Look, we got those 4s happening. We like those when they cancel, don't we? So that gives us 1/3. Now that's from that first parenthesis. Now, we're going to take this 1/3 and we're going to bring it right on over here and kick in with this 2/3, all right? And you look at that and you say, well, Ernie, can we cancel those 3s? No, we can't because it's horizontal, right? So what we can do is multiply 1 times 2 and 3 times 3, and that's all she wrote. That's as good as that one's going to go. That one's where it flies. That's where it ends. And again, watch what you're doing, all right? Watch out what you're doing in those. Take it step by step, all right? Now, I mentioned something about parentheses, didn't I? Let's look real quickly at one that I did put the parentheses in there with, all right? And this one says we're going to start with, write it down at home, we're going to do the multiplication first because there's parentheses, okay? We'll get the division on the end. It does make a difference. So let's put that 3/4 times 2/3. Lots of cancellation going for you here. The 3's go away, making a 1. The 2 and the 4, how about it? A 2 and a 1. We got a 1/2. So our real problem now is 1/2 divided, 1/4 divided by, I'll get it right, divided by 1/2. That's where we go. Now, 1/4 has not changed in any way. It's not going to change because it's basically our starting base here. But what we're going to do, we're going to divide that by 1/2, which means we have to change. Yes, we do have to change to the reciprocal, the big R word. 1/4, and we're going to multiply it times 2 over 1. And you know what's going to happen? It's pretty. It's nice. It's a 1 and a 2 again. Boy, we love that 1/2 in this problem, don't we? So you take a 1/4, you divide by half. It's like saying, how many pieces do you have now? You've got 2. And actually, you've got 1 out of 2, which is 1/2. All right. So watching what happens, remember 1 times 1 gives you the 1, 2 times 1 gives you the 2. Don't forget, got to put that 1 over the 2, make that fraction work. 1/2. Love it. Love it. Hope you've had a good time today with us on T and Learn Mathline Summer School. We've been triple, like I said, it was triple the fun. We've had triple situations all over these problems with fractions. But you know what? If you can do 2, you can do 3, and you can do more. And you know what? We're going to find some more things to do. See you tomorrow.